Okay guys, let's look at the Newton's method to solve the question number 9. So let's take the question number 9 and we'll solve it using Newton's method. So the question says use the Newton's method to find all the roots of the equation 6 decimal places. So what we can do is, first, what is the Newton method says? You have to write the definition of the Newton method. Okay. X n plus 1 equal to xn minus f of xn over f dash of xn. This is Newton's method. So we need f of xn and f dash of xn. So let's define from this function. We'll arrange this function and take f of xn. From by differentiating that one, we'll take f dash xn. That's our first step. We'll do that one. Then we have here sin x equal to x square minus 2. Take this to one side. Sin x minus x square plus 2 equal to 0. Then this is our f of x. X equal to sin x minus x square plus 2 equal to 0. Then we'll find the f dash x. Differentiate with respect to x. Then we get f dash x is equal to cos x minus 2x. So what we can do now is we can arrange our formula by using the our f of x and f dash x. Then we can go like this: x n plus 1 will be equal to x n minus sin x n minus x n squared plus 2 over cosine of xn minus 2 xn. So we have arranged the f of xn, f dash of xn by our functions. Then what is when n equal to 1, let's say when n equal to 1, but we'll get x2 equal to x1 minus sine of x1 minus x1 square plus 2 over cosine of x1 minus 2 of 2 times of x1. So x1 is our first approximation. Let's define x1 equal to first approximation. You must select x1 very close to the value of the root. That is the first approximation, but the approximation should be very close. But if you solve using in the calculator this function, you will get an answer about 1.728 like. So your first approximation is, if you take 1, it's okay. So just choose our first approximation as 1. Okay, let's take our first approximation as 1. So we are taking 1. Then therefore x1 is equal to 1. Then we'll substitute x1 is equal to 1 in this equation. Then you will get 1 x2 equal to 1 minus sine 1 minus 1 squared plus 2 over cosine of 1 minus 2 into 1. If you simplify, then x2 will be 2.26 154271. We now find the x2. When n equal to 2, it means in this function, if you put n equal to 2 here, n equal to 2, you will get x3 equal to x2 minus sine of x2 minus x2 square plus 2 over cosine of x2 minus 2x2. So we know the value of x2 we got here. So what we are going to do is, we are going to use this x2 value and we are going to substitute here in the place of x2 and simplify. Then x3 will be 1.8 0, 7, 3, 3, 4, 4, 2, 2. So similarly, you have to repeat this again and again, whereby when putting x equal n equal to 3 in this one, and you get another function and put this value on that one, and you have to continuously do repeat this step until you get the same value across, same value as the answer by repeating steps. So we can do it very easily by using a calculator, but you have to program your calculator. That's the important part. So let's see how can we do by a calculator. Just I'm going to explain the steps. Alright. So most of you are using a scientific calculator. The model number is Casio FX 991ES plus. So I like explaining the steps when following that. So first step is you have to check whether your calculator is in radians. So most of probably we are using degrees, but in this question we should have radians. So we have to check whether your calculator in the radian. Let's say first step, right? Uh, it's using calculators to find Newton's method. Underline this. So what our first step is, check whether your cal is in radian mode. This is important. After that, your first approximation. Select your first approximation. First approximation. In this case, we are using x1 equal to 1. Second step, writing the program. So first how to write the program. Third step, writing the program. Right. So you press our, because our initial approximation is 1, we have to start with that. So what you have to do is you have to press 1 in your calculator in comp mode. Press 1 means press 1. Press 1, then equal, then press equal. After that, you have to build a formula in the calculator display like this: answer minus sine answer minus answer squared plus 2 over cosine of answer minus twice of answer. to build this formula in the calculator display. Then other steps are easy. After building that one, just press equal. Then you get all the values. After you pressing equal, you get the value 2.26154 again equal. Again if you put equal, you get 1.8 1.807334422. Again if you press equal, you get 1.73087246. If you press again equal, you will get 1.728468707. Again if you press equal, you get 1.7 1.728 466,319. Again if you equal, you get 1.728466319. Again if you press equal, you get 1.728466319. So after a limit, you get repeated functions, repeated numbers like this. So you have to stop from that limit. So your final answer will be that. Then your final answer 1.728466319. It's your final answer for the Newton's method. So guys, I thought the question was finished, but while I'm doing this question, I got a small doubt, because in this question it says use the Newton method to find all the roots of the equation. So this equation is a contradict, like we have two roots. If you sketch this function, you get function like this: x-axis, y-axis, and you will get a function this. This value is 2. Basically, you want something where you put 2. This is very close to minus 2, and here is 2. So this is the function we will get if you plot the graph for this function. Y is equal to what is yeah, sin x equal to minus x squared plus 2. Sin x minus x squared plus 2. So we have found this positive root. This root we know. We have found that this root we know. No, we have found the answer 1.7 because it's close to 1.7. Counting 1.7, 1.7, That's fine. What about this? This point. We have to find this point also. So to do that one, in the same equation here, select your approximation. Select your first approximation as -1 because it's close to -1, right? So you use your first approximation as -1, you can get the root of this value. So use your first approximation. First approximation as -1 and repeat this function again. Repeat this step again. So take this step. Okay. Repeat still this step again. Okay. After repeating this step, for your first approximation is -1, then you press equal and program this function. And if you let's do this, and then pressing -1, you get set of values and you will get the root. Minus. Let's check this one. So in minus answer square, right? Answer square plus 2. I'm checking in my calculator, so please hold a bit. Sign of answer minus twice. So our x2 value will be minus 1.0624055571. Again we get minus 1.0615499933 minus 1.0615497775. So it started to repeat. Minus 1.0615499933 49775. So this is the root. This is our root. So this is our negative value here. That is minus 1.061549775. So you have to write both answers because the roots question is the roots of the equation. So we have already found one root and the final answer will be changed, and you have come up with minus 1.061549775. Please check this out because I even do this one because just when I'm teaching only I got this idea. So please check this out.